Hey everybody, Linus here. Today we're going to explore a fundamental concept in the world of computer networks. Today we're diving into the world of computer networks and talking about something called IPv4. This is one of the core technologies that makes the internet work. You know how in a city every house needs a unique address so the mail gets delivered to the right place? Imagine if two houses had the same address, chaos, right? Well, IPv4 is like that, but for computers on the internet. Each device needs a unique address to communicate effectively. IPv4 stands for Internet Protocol version 4. It's been around since the early days of the internet and is still widely used today. It's a set of rules that lets computers talk to each other online. Think of it as the language that computers use to send and receive data. Without IPv4, your computer wouldn't know where to send requests or how to receive information on the internet. It would be like trying to navigate a city without street names or signs. It's like trying to send a letter without an address. It just wouldn't work. So, IPv4 is crucial for the smooth operation of the internet as we know it. So, how does IPv4 actually work? Well, every device on a network using IPv4 needs a unique identifier. That identifier is called an IP address. You've probably seen them before. They look like this: 192.168.1.1. These numbers aren't random. They're divided into 4 sections separated by dots, and each section represents a part of the address. Think of it like a street address: country, city, street, house number. This system allows for billions of unique addresses, which is a lot, but not enough for our increasingly connected world. You might be wondering, who decides which computer gets what address? Well, it's not as chaotic as it might seem. IP addresses are assigned by organizations like Internet Service Providers, or ISPs. Think of them like the post office of the internet. When you connect to the internet, your ISP gives your device a unique IP address. This allows your computer to communicate with other devices on the network. It's like getting your own unique mailing address for the internet. Section 4, Packets on the Superhighway, How Data Travels with IPv4. Alright, so we know what an IPv4 address is and who gives them out, but how does data actually travel across the internet using these addresses? Let's dive deeper into this fascinating process. Imagine the internet as a massive network of highways and data as cars traveling on those highways. Just like cars need roads to travel on, data needs pathways to move from one point to another. Each car needs a destination address and a way to navigate the roads. Similarly, each piece of data needs an IP address to know where it's going and how to get there. In the world of IPv4, data is broken down into small packets. These packets are like individual cars, each carrying a piece of the overall message. Each packet has the sender's IP address, the receiver's IP address, and a piece of the data. This information is crucial for the packets to navigate the network efficiently. These packets travel across the internet, hopping from one router to another until they reach their destination. Routers act like traffic signals, directing the packets along the best possible path. The receiving computer then reassembles the packets like putting together a puzzle to get the complete message. This process ensures that even if some packets take different routes, they all arrive and fit together perfectly to recreate the original data. Section 5, IPv4, Today and Tomorrow. Today we dive into the world of IPv4, the protocol that has been the backbone of the internet for decades. IPv4 has been the backbone of the internet for decades, but it's starting to show its age. With the rapid growth of the internet, the number of available IPv4 addresses is dwindling. Remember how we talked about IPv4 addresses running out? This issue is becoming more pressing as more devices connect to the internet. Well, we're getting close to that point. The pool of available IPv4 addresses is nearly exhausted, and this could lead to significant challenges in the future. That's where IPv6 comes in. IPv6 is designed to address the limitations of IPv4 and provide a much larger pool of addresses. IPv6 is like the next generation of internet addresses. It offers a vastly expanded address space, which is crucial for the continued growth of the internet. It's got a lot more addresses to give out, ensuring that we won't run out anytime soon. And some cool new features. IPv6 includes improvements in areas like security, routing, and auto configuration. The transition from IPv4 to IPv6 is already happening, but it's a gradual process. Many networks are running both protocols simultaneously, and it's going to be super important for the future of the internet IPv6 will enable the continued expansion and innovation of internet technologies, but that's a story for another time. We'll explore more about IPv6 and its benefits in future videos. So, keep those packets flowing, and stay tuned for more exciting content, and I'll catch you in the next video. Thanks for watching.